Hello? Hello. So this cryptic title really means that I want to talk to you about databases, and not about databases in specific or about any specific things. So I will not tell you which database to use or what is actually out there. That I leave to you. Instead, I'll try to tell you and probably even show you what I chose and why, and essentially what was the process and what mistakes I made and what decision I think I made correctly. So at the end, we'll see whether you agree or disagree, and we will hopefully have some interesting discussion. So this is essentially a journey through time. It is journey through my time as I evolved, and what I started with, and how I went from one stage to another. And it's also structured in a way that how I think projects should actually evolve. What's important in the beginning and what's important as you scale, and how to make the decisions of how to move to the next stage. So my past is this. It's an enterprise thing. It's a big iron machine with big database on it. This was back in 2005 or 6. It was one machine with an Oracle database that had 6 terabytes of data. It was really impressive what you could do with it, and it was also impressive how much it cost. And not just in terms of money, but also in terms of manpower and education and knowledge. We need to have an entire team of DBAs to keep this thing up and running. Once one of them made a mistake and dropped a different index by mistake, and we all took a few days off because the machine was unavailable for days. So, but it also taught me of what's possible. That SQL really can be this godlike thing that allows you to do everything. From solving crossword puzzles to selecting the top 10 best candidates for the job. So this was my background. This was what I knew when I moved to a completely different world. A world of startups and web applications and rapidly moving engineering effort. And some of the principles that I knew from before were very useful. Just the knowledge that I knew what was possible, that came in very handy. But it also made me screw up a lot of things, because I couldn't adapt well to the paradigm shift. That I no longer have a team of DBAs and a massive hardware somewhere, and I actually need to be smarter because of that. And I need to learn a little bit of a different game on the field. So this is what I learned after all my screw ups. This is the that I think any beginning project should, and that is at the beginning, optimize for developer happiness or for development speed. So use the simplest tool possible. So if it's more comfortable for your developers to develop using SQLite on their local host, you should allow it. You should optimize for it, and you should make sure that the onboarding of new people is as painless as possible. That means automation. So you should automate the setup of the project to get up and running as fast as possible. By the way, this is one of my biggest arguments for unit testing and everything, because if you actually have a good unit test suite, then you have the setup somewhere buried in that code. So all you need to do is extract it to a script that you can run whenever you want to start working on a new project, and you have your environment up and running, including all the data to get started. So this is one part of it, to optimize for the development speed and the developer happiness. The other part of it, you probably don't need to overcomplicate things. You are not building a Large Hadron Collider. Or if you are, you're in completely different conference. Like, I'm guessing here no one actually built these things, and no one needs to build things as complex as this one. Cool. I'm impressed. No, this is amazing. This is amazing that people are capable of doing that, and they really need to build complex things because that's sort of the definition. We don't. First, we work in intangibles, so we can change at any time. We don't need to physically drill a tunnel of 27 kilometers. We don't. We work in bits and bytes that are very simple to manipulate. So the first thing that you should ask regarding databases is, do I even need one? Like seriously, like do I need one? A friend of mine, Jakub, who actually started his own startup recently, his first 3 versions didn't use a database. He prototyped everything just using Python dicts, and it was enough. It was enough to get the prototype out. It was enough for the first few versions, and then he realized, yeah, this is how I use things. So the easiest thing for him was to take this very same dictionaries and just put them somewhere in a database. So he just chose Redis because it naturally matched the operations that he did on the dicts. And that's perfectly fine. When I say it simply doesn't necessarily mean a SQL database. It means whatever is the simplest. Best database is, no database is the best database because it will never fail. So, and it's ultimately the fastest one. So, still 90% of applications out there will choose to start with a SQL database. And even there, even inside the lesson still applies. The lesson that I failed at utterly. So this is the schema while simplified it a lot. And this is just one part of an application that actually does nothing else than it's just its CMS. So that was my first big failure, that I overcomplicated things. I tried to account for every possible feature that we would ever want from the get-go. I tried to be flexible. I wanted it to be clean, a clean design. At that point, I still remembered what the normal forms for a relational database should be, and which one I should choose, and all the theory behind it. So this was actually, before this, it was in the 3rd normal form, and it was all perfect and nice and didn't work at all. So that's the other lesson. Do the minimal that you have to do. We've already pretty much all accepted that for project management, the agile way makes sense, because change is going to happen. So we should adapt to it. We should account for it, and we should optimize for it. So I'm saying we should do the same thing for our data, for our schema. We should start with the simplest thing possible and learn to evolve it. Make it a practice to be able to do it, instead of trying to solve everything up front in a waterfall-y fashion. So that would be the first stage of a project. Start simple. Start small and start slow, and optimize for the speed of development and the ease of onboarding people and growing the project. Because you never know where you might end up. Chances are that even if you devote months to develop the perfect schema, you're still not going to get it right. And there will be changes along the way. And if you're not comfortable with making those changes, then the changes will hurt. If you start slow and a database change is something that you do every other day, then you will not be fazed by it at all, and you will just be able to move on and on and on. And you get the picture. So this is the first stage. This is where you begin you build your first prototype, you verify that everything works, and you move on. Chances are that will be enough. If it's not, then I have a second advice that I learned the hard way, and that's commit to your database. And yes, I'm perfectly aware that I'm saying the complete opposite that I said earlier, and that's okay. There are different stages of projects, there are different stages of your career where different things make sense. So at the beginning, it was worth it to make everything simple for the people, to make sure that they can run SQLite on their machines to get them up and running faster. But later on, the price of actually keeping your code generic is probably will grow too much. And you will probably benefit more from just choosing one database. You can sort of see what my favorite is. And commit to it. Use all the features, see what's there, and don't be afraid to sort of lock yourself in that database. Because only that way will you get more out of it. Otherwise, you're just wasting resources. You have this amazing database sitting on your production boxes, and you're only asking them to do 20% of what they're capable of. That's not fair. And in the end, it's that the generic tools are very good for generic stuff. That's pretty much the definition. That's pretty much what they are. They are the least common denominators of all the possible functionalities of their underlying infrastructure. So if you use Django ORM, you are limited to what MySQL and SQLite can do. Fun, huh? So if you stick strictly to generic tools, you cannot store JSON in your data. You cannot store arrays. You cannot search in the Polish language. You cannot do a lot of stuff. So that's why my second advice to you is commit to your database. And I learned this again the hard way, where the product, the CMS that I am talking about, still runs on anything, SQLite, MySQL, Postgres, and it sucks. Overall, the CMS, I think, is pretty okay, but this part about it sucks, and it costs us a lot of effort and a lot of time to actually make it work across all these machines, all these different engines. If we were to instead pick one and optimize for it, we would have been much better off. So don't repeat my mistakes. Commit to one database. And things are going to get better. If you use Django, there's this wonderful guy called Mark, and he created a Kickstarter to actually introduce a lot of the Postgres-specific features into Django's ORM to actually expose them directly to you. So the decision to commit to Postgres has just gotten easier. So people who still think that their application should run across all the different database engines in, for example, Django's, they're running out of excuses. So things are getting better, and we're slowly getting there. So hooray for Mark! And if you haven't supported his project, then I guess it's okay, because enough people actually think that is important. So that's the great thing about open source. If enough people care, you don't have to. On that, please. So the downside of actually committing to one database is many people are scared. What if I have to ever switch? What if there comes a time where I need to run on MySQL? What if a migration happens? What then? So the first is what I've already said here. Probably the chances are that the cost that you've already sunk into the ability to run across multiple data stores is more than you would have otherwise paid for a migration. So it's plenty times it's actually easier and cheaper to commit to one and then let commitment than to sort of defer the decision and postpone it over and over. We've heard that procrastination can be a good thing, but it can also be a bad thing. So, for example, for us in our CMS, we originally had this complicated schema where we had tens of models. So we had a different model for an article and for a gallery and for a video, and that meant that everything else in the system that was tied to one of these objects had to, again, be generic. It had to be able to bind to any object. So we had to use a lot of generic foreign keys for those of you familiar with Django. And again, that's something that's not efficient at all. not just in terms of performance, but also in terms of ease of development and the overall complexity. It was unnecessarily complex. So we decided to change it. We decided to introduce one model called publishable and have all these other models like article and video actually just inherit from it. So we actually just used concrete inheritance in Django. And everything was much more elegant. We had literally half the models that we had before. And everything worked. And I didn't want this step. For months, I was opposed to it because I knew that it would make everything simpler, but I was really scared of the migration. It ended up taking a week to do, to develop, test, and then run in production. I was super surprised myself that it's actually not that hard. People believe that migrations are hard and that we should avoid them at all costs. It's actually not that big a deal. It's mostly psychological that it's something that we are not used to, and it's something that's difficult to test and optimize and verify. But in the end, it's just taking data from one side and dumping them in the other. If it's just a schema migration or something, it's even inside the database. It already has all the tools to make that happen. I have another example of a migration that seemed to be scary. We had one side running completely different CMS, and we wanted to migrate it to this one. And I was really afraid of the data migration because we had hundreds of thousands of articles and comments on it, numbering in millions, that we actually had to move. And I was like, how am I going to do this? We're going to end up with completely different IDs, and how are we going to make that happen? And then I actually thought about it. Over 1 million comments. So even if I have to change all the IDs, all I need to do is create a dictionary in memory to actually translate it during the process. And that's perfectly doable. You can, on any machine that you currently have in your pockets, I'm pretty sure that you can create a Python dictionary with 1 million items to actually translate the IDs. People don't realize this, but when you have 4 gigabytes of memory, 16 gigabytes of memory, you can load pretty much all your entire database into memory, or just the IDs if you need to change them, and just do this all on the fly. So the migrations are not as scary as you might think. So hopefully I've dispelled some of the fears of committing to one database. So now we're in a good spot. We have a mighty database that can do anything that we want. It's running perfectly fine, and we're using all its potential. We are using the features that it has, and everything is fine, until it isn't. So even a mighty database can run into problems, or can have some use cases where it's not ideal, that it wasn't actually constructed for. Yeah, that's where this analogy fails, because it was actually constructed to do this thing. But an example of one such use case would be this. Does anybody know where the problem here lies? The offsets, the counts, yes. So the problem is the depagination. The problem is the button with the 4 letters on it, last. That's a scary thing. If you have 80,000 results and you want to see the last page, that's going to hurt you. The reason why this is going to hurt you is because what the database needs to do. It needs to retrieve 80,000 records from the disk. It needs to unpack them into memory to extract the value of a field. Then it needs to sort these 80,000 rows based on the value of this field. And then it will discard 79,995 of those. Fun, huh? So it did all this work for nothing. And I literally mean all this work because it all needs to fit into memory. And this is something that was literally killing our servers when somebody hit the last button. So obviously the solution is hide the button, right? Sure, That works, and many sites do that. They'll only give you the first 10 pages and nothing, or even if they give you all the pages, they only expose it through next, which nobody will get to the 1000th page. Well, nobody alive. But if you so happen to have something on the last page that you still want to be searchable, if the droids you're looking for are at the last page, you need Google to be able to go to the last page. So you need that last page to be available, to not kill your database, to not time out. So how do you do this? So you can, of course, you have a powerful database, so you can make it even better. There are many different approaches that you can do to make this use case scale. You can make sure that the IDs are sequential, so you can actually just do just range query essentially instead of the limit and offset. You can make sure that everything is stored in a sorted order. You can introduce additional tables and indices that will make all these things easier. But in the end, all what you're doing is making the database into something that it's not. You're circumventing a lack of functionality, and you're using the wrong tool for the job. Instead, what I prefer to do to solve this situation is to use the right tool for the job. So in our case, we looked at the query pattern that we need. That's always where everything about databases starts. Like, what queries do I need to run? So in this case, we needed pagination. We essentially had a list of some things, and we wanted to get the number 80,000 to 80,010. And it so turns out that the data store that can do this very efficiently is Redis. So we started using Redis as sort of a secondary index for our Postgres. So it would prepare the data and then feed it into Postgres. And Postgres did what it was good for. It would take all the IDs that came out of Redis, and it would just retrieve the rows, primary key access, very fast, very efficient. Everyone was happy. So we bought ourselves a lot of time. Our database is no longer dying. We solved that issue. And we sacrificed very little of the flexibility because A, we still have everything that we had before. We still can use Postgres. We still can do the pagination there even. So even on the development machines, we don't have to turn the Redis optimization on. We can just have the developers locally still use Postgres and they'll be fine. So we haven't complicated their setup anymore. And what we introduced on the other side as the detriment is we now have a need to synchronize things. So how do you deal with the synchronizations when you have two data stores? In our case, and honestly in most cases that I've ever seen, it's fairly simple because you have the master store somewhere. You have one master version of truth, which would be the Postgres instance in our case. And then you just need to essentially denormalize things into Redis. So this is solvable with two simple things. First is a batch job, something that's idempotent, so that means that you can rerun it at any time, and it will always pick up where it started. That's very important for something that potentially can take a long time to run. And also it will enable you to, for example, run it every night. And it will just take all the data that's already there and just see if there is anything missing. And it's actually not that hard to write such a job. There are many patterns that you can utilize. And the second thing you need is sort of the ad hoc synchronization of things that are being modified in Postgres. So with Django, that's fairly straightforward. Yeah, with Django models emit signals whenever something changes. So there is a signal called post-save, which will be triggered whenever a model actually is saved to the database. So you can very easily tie your code to that signal handler and just say, yeah, sure. So whenever a document was updated in the database, update it also in Redis. And that's actually fairly simple to do. And there's a third thing. I know I said two, but the third thing is more infrastructural, and that is you need to update the developer script, unless you are still having them use the Postgres directly, to be able to make this sort of the part of the setup process, which is easy again, because you have the bad job, and you have the script to set up their environment. So all you need to do is set up their environment, make sure then Redis is running, and then run the bad job. So again, the developers are still okay. They're still happy. They're still fast. So that's the synchronization. Now there's another challenge that we come when it deals to databases. And I've been guilty of this myself too. And that is, I discover a data store and I introduce it into our systems. And it's cool. It's oh so cool. So I want to use it everywhere. I want to migrate to this data store. I want to abandon Redis because it's old and gray and big, and I want to use this new shiny toy for everything because it's fast. And I probably don't have to tell you that that's not a good idea. There is nothing forcing you to only have one data store. You should not try to chase the silver bullet. There is no such thing, and it will hurt you. You just use this as a supplement to your data store that you already have tuned and you're fairly happy with, except these few things. You don't know what you don't know, because you don't have to know. Because you're starting with just, again, using the 1%, the 10% of the functionality of the other tool. So you don't have to investigate everything. That makes this process efficient, that you can just take Redis and plug it in without actually knowing 80% about Redis, 90, whatever. You can actually know just a very few things, and of those you need to be sure. But you don't need to know everything. If you try to view it as a silver bullet, you need to know everything, and that's expensive. That takes a lot of time, a lot of effort. So, if you were to ask 5-6 years ago what the next stage of the process would be, I would probably tell you that, yeah, now we need to find the perfect database that actually can solve everything. And so we have the Postgres, we have the Redis to it, and now let's find something that will replace it all. And this is a trap I fell in when we decided that we needed some analytics. So we have a CMS, and we publish some articles, and there are people reading those articles, and there are people commenting on them, and we want to see which author has the most comment on their work, and who is the most popular commenter, or which article has the most lengthy comments, and where it's actually just a flame war of +1s and -1s. So that's analytics. And at that time, I heard plenty of blog posts how MongoDB is amazing for analytics, and it can handle big data, and it's schemaless, so you can just load anything in there. And I believed that, because it was cool, and it made sense that, yeah, sure, it's about time that someone came up with this database that I've been dreaming of for the past year or two. And there's a slight problem with the internet. Even back in the day, Abraham Lincoln said that the problem with the internet is that you cannot really trust anything that you read on there. You don't need whether it's true or not. And who am I to disagree with him? I mean, obviously he said this, so. So the lesson of this stage is trust no one. Instead, test it yourself, verify the things that you read, and it for the use case that you want to use it for. It's okay not to test it for everything. It's okay not to play around with the clustering feature or the replica sets or whatever if you just want to use this one thing. That's the beauty of the approach, that you only care about the limited part. But that part, you need to be sure. So test that. Don't just give in to the hype. Don't be like me. So now, again, we are in a good spot. We have Postgres running in production with Redis optimizations. We have tools to synchronize those two. We still have tools to make the developers happy, to make it simpler for them. And we're running on. So what's the next step? So the next step is a hard one. It's a hard one because it's not actually moving forwards. The next step is you go through your code base and you look, where else can you use this? You've used Redis for pagination, so where else do you paginate in your code base? Can it be adapted? Can you change it? Can you see a pattern there that you can reuse over and over? So in our case, it was indeed the case. So we had forums on the website. And previously, you could only sort by a few criteria. You could sort by the last visit, the last comment, or the day it was created. But for example, we didn't even bother to track like how many visits this thread got, because we were afraid that Postgres wouldn't handle it. Not because it's a bad database or it couldn't be scaled that high. We knew that it was possible, but we didn't want to invest that much time into it. Because we were not DBAs, we are developers, and we want to move forwards, we want to develop new features. We don't want to babysit our database. We don't want that team of 10 DBAs sitting in a corner yelling at the developers and trying to fine-tune indices, storage and everything. So we never tried this feature. But now we thought, hey, we're using Redis for pagination, and there are a few things that Redis is good at, and updating, that's one of them, definitely. So if we realize that we have 1,000 visits per second, and we want to increment Redis every single time, sure, no problem. That's easy. Redis can do that. So that actually enabled us to introduce new feature based on what we already had. We just took a pattern that we developed to save our asses, to keep ourselves from dying whenever Google came knocking, whenever Google did the last page and find the droids. And we turned it into a new feature. So that's sort of the review. Take what you implemented and see where else you can apply the thing. So look at all the pagination code. We also use this for paginating comments and for pagination in the admin and everything. Everywhere where pagination was used, we just replaced it with the same code. We saved our Postgres a ton of grief, and again, it gave us more breathing room and more time to actually work on features and not on actually trying to maintain the infrastructure and make sure that everything is running. So that's the review process. Take what you learned and apply it back. But we can actually go further. You probably at this stage, you want to explore. You want to see how rabbit hole goes. You want to see, so now I have Redis in my system. What else can I actually use Redis for? It's a good question. What are the other features that we never thought of because we didn't have the tool for them? What are the other options that we discarded because we didn't have a tool capable of actually sustaining them? So now is the time to revisit them. We introduce a new part into our infrastructure. Again, it's time to double down on it, to commit on it, and see where else can we use this. Pagination, good, works. What else? Can we use it for caching? Yes, absolutely. Will it make more sense than Memcache? Yeah, probably. So let's do that. And so on and so forth. So you've added another tool to your arsenal. You have to go back and see how it actually expands the possibilities, the possibility space of what's doable and what's reachable. In our case, the biggest one, literally the biggest one, was the Big Live Show Live. This was a project that we had. It was a live show. It was live. It was big. The name sort of gave it away, but it was actually really big. And the idea was that we want to have this live video broadcast from our offices over 4 or 5 hours or the whole day, and we wanted to have a live chat next to it. So live chat, that was something that we never considered before, because we never had the tools, we didn't have the expertise. Now we have. Now we have Redis in our systems that can do live stuff. It can do sort of the publish subscribe things, and it can do it's fast enough to actually support 20, 50,000 people in one chat room. So we thought, yeah, we can actually do this. So we went and we actually implemented chat on top of Redis. The first version handled 5,000 users, and then it fell off. The second version, 10,000, and the third version actually went all the way up to whatever we needed. So we didn't actually find out how many users it will handle. So that's one thing that we learned. We can actually use Redis to implement the real-time web. At that time, that was all the rage. So we jumped on that wave, and we actually managed to do it. And there was an interesting side effect to that. What we ended up doing to sort of scale the chat is we used Redis replication. So we had one Redis that all the chat messages went into, and then we had a small Redis slave on each server that had a web server, that had a Junicore running. So all the reads would happen locally, over localhost, over TCP socket, so no overhead whatsoever. And the amount of data actually in Redis was minuscule, so no one cared. And this enabled us to scale really well. That's how we got over the hurdle of 10,000 users. And again, we went back and saw, yeah, this is a good pattern. Where else can we use it? Caching. So we actually used the very same pattern for caching. So that made everything blazingly fast. Because when you cache something and you know that you can read it locally from local memory, avoiding even the overhead of TCP traffic and just going through Unix sockets, that makes a lot of difference. Sure, you have to take care to have enough memory on all your boxes for the cache, but for most sites, that's not a problem. And even if it is, it's a simple problem. And by simple, I mean it's solvable by money. So it's a very simple equation, like how much performance will it give us versus how much money more it will cost us on RAM. So again, we saw a pattern, we identified it, and we saw where else we could use it. And that's pretty much it. The rest you need to do is just keep iterating over this process. Identify the bottleneck. Solve it. Solve it everywhere. And then see what else did you gain along the way that might have been just a beneficial side effect. So what else is there? What do you need to actually make this happen? Now comes the boring part. You actually need to be able to identify the bottleneck, which means that you need to have monitoring. You need to see what's happening in your systems. You need to be able to debug it. So whatever you use, you need to have something, and it might just be a person viewing your logs or a crystal ball on your boss's table. It doesn't really matter what it is, but you need to have a tool that will tell you what's happening in production and enable you to zero down on where the bottleneck is. In our case, that was actually fairly simple. All we needed was a Postgres slow log. And then also what we needed was something to identify when a request timed out to see the URL. It literally doesn't need to be any more complicated than this in some cases. In other cases where you have more complex infrastructure, you probably need more. That's another argument for not having complex infrastructure. Because just to discover what's going on so you can actually make sure that it's working or that you can fix it when it's not is a very powerful argument. So that's it. Those are the tools that I discovered and the processes I discovered to help me and to guide me sort of through this process. So this is what you should take away from this. Like, simple and fast. Just optimize for speed and for convenience. Don't bother about the future. It will come and you will solve it, or not. But chances are that whatever you do to prepare for it is not going to be enough anyway. So you might as well have some fun and actually do some features and actually just keep moving forwards. Second one is use what you have. Use it. Use all of it and use all its potential. When you have a smart database, don't treat it as a dumb one. Discover, try to learn about the features and where you can use it. And if it's something where it's failing, where it's not enough, find something that is. Find something that will supplement it, or maybe even replace it, or replace parts of it. And use that one. Plug it in, and then spend the time to learn about that one, so you know what else you can do. And then do it all over again, because that's fun, right? So it actually is, because you notice during my entire talk, it was always moving forwards. There was never a time where you had to go back and re-engineer everything, or you had to spend weeks on something. Still the most annoying thing was the migration. But again, that's a fun problem. That's a problem outside of your typical run a web application, make sure it's usable and fast and everything. It's something new and something exciting. So I actually enjoy this process immensely because it gives you variety of work. It allows you to scale very well and never stop moving. That's it from me, unless you have any questions, which are more than welcome. Thank you.
Okay, so if you have, there are many questions. I will start from here.
Hi Honza. We met in the Django sprint last time.
Cool.
Yeah, in base. Yeah, basically, my question is about synchronization. It's certainly a very tough problem. And you mentioned one way you're doing it, like using the Django hooks. And yeah, we had at one point when we tried to do something similar. And the problem here is that the Django hook, it's triggered before the database syncs. So you can have a point in time where, for example, you save some stuff in Redis, and then basically you didn't save it to Postgres, in your case, right? Did you ever hit this, or did you ever think of it, or something?
Yeah, so the typical answer to something like this is, do you actually care? Like, does it happen often enough, and is it such a big problem that you actually care? Like, isn't it okay to identify this problem ex post and fix it later? Like, for example, here you can actually detect that the transaction into Django didn't go through because there was an abort, there was an exception. So you have the information to go then fix it into Redis and revert to the back, revert back. Also, the chances of that happening are very, very small. So again, it's a trade-off.
Yeah.
Sure. And some applications cannot afford it.
When you grow in terms of scale, right? For example, you as a customer of some service, you don't want to see, like, for example, I think you don't want to have like a business software that you're paying for it, and then you just see your data screwed on your phone because some synchronization error.
Yeah. So there is obviously another part of this, and which is how do you then use it? Because for the reasons that you described, the synchronization might not be perfect. So again, the code that actually uses it should account for it. So the code that actually goes to Redis and then goes to Postgres should be able to handle if one of the IDs disappeared from Postgres in between, and just skip that one. So you will get a page with only 9 articles instead of 10. That nobody cares about. So that's sort of my answer. Make your code that actually uses this part more resilient. So these things don't phase you. Identify them, log them somewhere, so you can then later go fix them, either automatically or, God forbid, manually, and move on.
Thank you.
Sure.
All right, another one. Thanks for the talk, first of all. So my question is actually, your idea right now is to keep the always right state in the relational database and just put some things out of it to query it faster, right? Or do you actually duplicate this data or move out of the based database?
So first of all, I never said it needs to be a relational database. It just so happened to be in my case. It's the primary database that you chose in the beginning. And yes, so for example, we moved some of it out there. For example, the pagination example with the number of views, we don't keep that in Postgres. We keep that in Redis. So, and that brings about some additional problems. So it's, again, a decision that you need to make, because at that point you need to make sure to, for example, back up Redis as well. Or you can just say that you don't care if you lose this data. If you lose the page views for every thread, so you'll just reset them to 0. So, like, yeah, it sucks, but it's not the end of the world. Or you need to back it up. What we ended up doing is we have 2 Redis instances. One is for the denormalizations. So that one can be entirely deleted, that's not backed up, and that one it can be fully rebuilt from Postgres. And then we have a tiny one for stuff that's just kept in Postgres, and that we actually back up and treat as its own data store, which it is. Make sense?
Yeah, sure. Just another one. Have you actually considered, maybe besides of this project, event store, to store events before it actually gets to those databases to populate every store?
Yeah, so many things that we do here, we would go through Celery or something that would use a queue in between. And again, that really much depends on your use case. As we heard previously, some people cannot afford the delay. For some people, it's okay. So it really depends on the exact use case. As I said in the beginning, I'm not going to give you answers. I'm just trying to show you how to get them for yourself. And in this case, sure, just test it, see if it's okay. See if you can live with the delay, if your users can live with the delay, and if it's more valuable to you to just offload it to an event store and keep moving your code. Or if it's worth it for you to sit and wait for all your data stores to be updated and then move. It's just another question that you need to find the answer for your application.
Sure, thanks.
Sure. Any other questions?
Yes. You've mentioned that developers' convenience is a big factor. It's very important. So do you run your tests on Postgres, actually?
So we run them on both. Everybody runs them locally on SQLite. And then on CI server, we run them on Postgres. But that's because I went against my own advice, and I regret it still that our software is still agnostic. So it can work on SQLite. But yes, I would totally run them on Postgres. Once you commit to Postgres, you absolutely need to run the test on Postgres. And it's actually not a big deal.
Isn't it slower a bit, because like every time you create database and like
the difference between how fast Postgres and SQLite can create a database is very small. You can optimize the database to not f-sync. The difference is minuscule.
Okay, thanks.
So once you get to the point you have Redis, you have Postgres, you have Memcached, you have something or another, or Hadoop somewhere else. How do you test that all together, that everything works well together?
So that's a generic testing question. So if you have more components, how do you make sure it works? My answer to this, I test each separately, extensively using unit tests, and then I have a few integration tests that will actually go through all of them. And because each of them is tested as a unit, so I know what are the inputs and what are the outputs. The single purpose of the integration test is to actually make sure that the input and output actually match together. So the integration tests are very simple, are very few, and that's typically enough.
Do you run them as part of your regular test suite, or is it like separate setup or something?
I want to have the option to do both. So definitely the CI needs to run everything as in a setup as close to production as possible. And locally, I've recently just switched to using PyTest to actually annotate the different tests. So I usually just run the unit tests, and only before I push or before I commit something bigger, I run the integration tests as well.
All right, thanks.
Sure.
Hi, I'm curious about the first step when you said that do absolutely minimum to cover the functionality. So is it like absolutely minimum? It never backfired as you wanted to do something more, and actually you happened to be in a state when you had to completely do it again.
Sure, that happens. There is no advice that is absolutely correct. There are many different possibilities, many different contexts. And so for this, it never happened to me that I had to go all the way back or start fresh. But I had to backtrack a significant bit, yes. But then again, I didn't mind, because probably it wouldn't be something that I could foresee. And also when I see the minimal thing, I don't mean that you should not think about what it could be. So how I like to do these things is, I imagine if I gave in to my over-engineering needs and actually design it all up front, how would it look like? And then I try to do the minimal thing without actually shutting off the path towards the over-engineered solution that I saw in my head. So I don't write it, but I admit that I might want to get there at some point. So I just try not to shut off any path that leads to that design. Does it make sense? Thanks. So any other questions?
I think we have time for last question.
Last question. Going once. Going twice. Sold.
Yeah, that's going to be a quick one. How do you make the development environment really easy to set up if you have multiple data stores?
It's one script that when you run, it's set up. I don't care what's inside there. Just one script. It can be a script that you run automatically when you activate the virtual env, or it can be a script that happens on when you turn on your Windows machine. I don't care.
Sure,
it just needs to be simple.
Yeah, but then you have to actually start 3 database engines and populate some data,
Yes.
so someone actually can
Yes,
work
but
with
if you use this, you start with one, and you make it work, and then you add another. So again, it's incremental small steps. And starting Redis, seriously, that's one command, that's one line in any shell script, batch script, whatever. I'm pretty sure there is no language where it would take more than one line. Okay, Java, but if you use this way, you start with one data store, then you add another, and you already have the infrastructure in place. And it also depends on your developer. Some might actually prefer to actually make sure that they run it themselves, and your job would be just to populate it with the data and with the schema and with everything else. It's really up to your environment and up to the people that you work with, but it needs to be simple. Whatever simple means for you and your team.
Thanks.
Thank you.